Welcome to today's lecture on embedded system design. Contents: embedded system definition, examples of an embedded system architecture, characteristic of an embedded system, design challenge, optimizing design metrics, and summary. Embedded system definition: embedded system, a system having specific hardware with specific software and performs a specific task is called as an embedded system. Examples of an embedded systems: personal digital assistant PDA, printer, cell phone, automobile, engine, brakes, dash, etc., television, household appliances, PC, keyboard, scan keys. Autofocus cameras, disk drivers, electronics toys, games, medical testing systems, battery charger, cordless phones, digital camera, washing machines, etc. Embedded system architecture. Embedded system consists of sensors that are input devices in addition with memory, processor, output devices. In hardwired unit, we are having application specific logic, timers, A to D and D to A conversion. In embedded system hardware, software is embedded. That's why the total architecture is called as embedded system architecture. Characteristics of an embedded system: single function executes a single program repeatedly, tightly constrained. This is a low cost, low power, small, fast in speed, etc. are the characteristics of second type. Reactive and real-time system. This is a system that reacts to the changes in the system's environment. This system must compute certain result in real time without delay. Key design challenges: optimize numerous design metrics. Design metrics is a measurable feature of an embedded systems implementation. Optimizing design metric is a key challenge. Common metrics: unit cost, the monetary cost of manufacturing each copy of the system, excluding NRE cost. NRE cost is non-recurring engineering cost. The one-time monetary cost of designing the system is NRE cost. Size, the physical space required by the system is the size. Performance, the execution time or throughput of the system. Power, the amount of power consumed by the system. Flexibility, the ability to change the functionality of the system without incurring heavy NRE cost. Common metrics: time to prototype, the time needed to build a working version of the system is time to prototype. Time to market, the time required to develop a system to the point that it can be released and sold to the customers. Maintainability, the ability to modify the system after its initial release. Correctness, safety, and many more are in the maintainability. Design matrix computation. Design matrix consists of performance, power, size, and NRE cost as a key parameters. Software and hardware is needed to optimize design metric. A designer must be compatible with various technologies, and a designer must be compatible with both hardware and software design. Time to market. Time required to develop a product to the time it would be sold in the consumer. Market window. Period during which the product would have highest sale is the market window. Average time to the market. Constraint is about 8 months. Delay can be costly. So this is the window in which we are having on-time entry and delayed entry. So product life is of 2 weeks. Peak is at 1 week span. This is 1 week span. Time of market entry defines a triangle representing market penetration. Triangle area equals revenue. Loss, the difference between the on time and delay time triangle is called as on time, and delay time triangle is called as loss. Cost. First cost is unit cost, the monetary cost of manufacturing each copy of the system excluding NRE cost. NRE cost, the on-time monetary cost of the designing system. Total cost, NRE cost plus unit cost into number of units. Pre-product cost, total cost divided by number of units. NRE cost divided by number of units plus unit cost is pre-product cost. For example, we are having NRE cost that is $2,000, unit cost is $100. For 10 units, total cost calculation is like this. That is, total cost is equal to $3,000 and pre-product cost is $3,000. If we are comparing the technologies by cost, then best depend on the quality. Technology A, NRE cost is 2,000. Technology B, NRE cost is 30,000. Technology C, NRE cost is 100,000. So we must consider the key parameter, that is time to market. Summary. In this session, we have learned embedded system definition, types of an embedded system, characteristics of an embedded system, design matrix of an embedded system. These are the references, and thank you.